Hello, everyone, and welcome back to another episode of Adventures in DevOps. And I'm joined today again by my co-host, Amy Knight. How you doing, Amy?
Pretty good. Walking again.
She likes walking. That's
I gotta get my steps in.
I don't have a good strategy for that yet. Yeah, so today I have to be completely honest. The topic is in and around FinOps, but I don't really know what FinOps is. But if it's anything like DevOps, I'm guessing it means firing all your business analysts and hiring some additional software engineers to do a job they don't understand. And then after years of failing, reappropriate the name to mean something else and claim success. Well, Amy, you're already smiling, so maybe you know something I don't know.
I'm actually laughing because it's very entertaining, and I also, I think like last week I realized your title on LinkedIn said tech entertainer, and so that was a very entertaining intro, and I think you did a great job.
Oh, well, thank you. So we pulled an expert from the field, Chief Strategy Officer at Cloud Bolt, Yasmin Rajabi. And I've noticed here, so you have a history of product management, and so I'm really excited to have you on the show. Welcome.
Thanks for having me. Excited to be here.
How completely off base was my thoughts about what FinOps is?
Not so far off base. I think anytime you put like an ops inside in one of the words, you're obviously trying to force some things together. And it's funny, a question I get asked often is like, okay, so how are FinOps teams and DevOps teams coming together? And the ops in FinOps is supposed to be for DevOps. So technically, like they're supposed to already be together. They're not supposed to be separate teams, but there's always the ideal and then the reality of if you take financial analysts and you take engineers and you want to bring them together, they speak different languages, they come from different worlds. So there are folks that are trying to use software to bring that together. I'd put us in the mix of that. But it's still like people from completely different worlds and trying to get them to think and care about the same topic.
Okay.
I was going to add too. We also need to add in, is it green ops? So we're like getting environmentally savvy
Yes.
as well within the realm of FinOps.
Okay, well, I realize that I need to reduce the waste, but I want to be able to measure that from a like my carbon footprint standpoint. And it was interesting. I was talking to a FinOps person that is using those metrics to drive people to care inside their organization because the people in the organization is like, okay, well, it's not my money. I'm not spending it. But when you actually tie it to the environmental impact, the kind of human nature part of people helps kind of get people a little bit more passionate about reducing the waste inside their organization.
As far as the green ops stuff, I did kind of laugh it off before, but I saw something recently about like as they're putting more and more data centers up, like the water shortage that's happening to the communities around them.
Some cities are literally like their grid cannot handle any more data
Yes.
centers coming online, and like they're starting to buy in different areas. Like it'll be interesting what things look like in 10 years.
Like I saw like these poor families, like literally like they can't run their appliances as they could like a couple years ago. Yeah. Anyways, okay. So
I think this is a really interesting topic because we've had a lot of our previous guests on the show, either they've been AI focused in the last few months or they've had a unique insight into data center operations. One of the ideas that keeps coming up is that it's actually not a struggle to get energy reservations for the data centers. But it's interesting that you bring up the water impact because that's a new thing that I'm not familiar with.
Where it kind of interplays with water is probably less of my expertise and background. Just the fact that you need the water to cool down the data centers. The more power it's using, then it becomes it's just like a cycle. Though I would say their ability to like use liquid cooling in the data centers reuses the water instead of an endless supply of water. The recycling the water that exists has at least helped make some of an impact. What's interesting is people are pulling these metrics out and trying to overlay them on their usage as well. So, okay, I'm writing an application, I deploy it. I never think about these things, but as I can start to pull some of those metrics out of either my cloud provider as they start to provide them, I think Microsoft started to pull in like carbon data and other metrics that you can pull out. Or if I'm running my own data center, then being able to pull those metrics out, then kind of overlays and says, hey, here's the impact of what you're doing. Like, make sure you're setting these things correctly. Otherwise, there's a lot bigger impact than just financial.
What's a good example of needing to pull in accounting or financial operations into a software development team?
So I'll say for most of my background in this space is on the Kubernetes side. And when you're deploying a Kubernetes app, you need to set requests and limits. One, from a reliability standpoint, to make sure you actually have the resources. But two, typically what people will do is just like set them really high so they don't have to think about it and then deploy the application. And it's really hard to understand the impact of that, especially because that's at the pod level and you pay for nodes. And you're like, okay, well, I don't really know how my pods translate into my nodes. So I'm paying some amount of money, but how do I actually know the impact? And so being able to pull in both the billing data and then actually allocate it correctly. Because one of the challenges in Kubernetes is, okay, how are you going to allocate your costs? Do you just look across namespaces and say like, okay, I'm divided by namespaces and then that's what you get? But what if you have a larger namespace, or you have how do you split out like cube system and all of anything on the control plane? That's some of the challenges that people have. And if you're what you need to be doing is pulling in that billing data to say, here's how it's costing you. Here's how we can split that out if we want to split up the pod level, and then you can be able to tie that back to the actual nodes that you pay your bill on.
So would it be accurate to say that historically maybe software engineering teams haven't been held accountable for how much they spend in the cloud?
For sure. And often what happens is the developers are setting those requests, and then the platform engineering team are the ones that are like, okay, well, we're managing the cloud environment. We're managing those bills. They get asked to do something about it. And they're like, well, I don't know the app. What do you want me to do? If I touch something, I'm going to get a phone call from probably not a phone call, a Slack message from a developer of like, hey, what do you do to my system? It's down. It's having challenges. You were the last one to touch it.
I see Amy having experience there.
Yeah, this is a very real problem. I would say like the requests and limits also, but then I think like if a scale gets large enough, you also need to understand like traffic patterns and scaling appropriately for that. Because if you're an early stage company, you can just kind of scale at like a relative level and stay there. If the app really grows, which hopefully it does, you're going to be hit with a like very realistic problem. It's going to cost a lot more money to be running your app at 9 a.m. versus midnight. If it's a global application, you get into having to spread apart things and allocate resources appropriately versus like the distribution of the requests coming in and things like that. So it's a very complicated problem.
And most of the time, the people that have been sort of on the chopping block for figuring this out have not been the engineering teams who understand what the application is doing. So how do you get that back? Like, how do you align the incentives appropriately so that if the amount of money you're spending on your cloud provider or on capital allocation for on-prem data center resources, how do you align that back with the software engineering teams?
I think a little bit of it is reporting, just giving them visibility. Some of our customers call it shame back reporting. I'm like, yeah, I get it, but maybe like don't call it that. But I think on the other hand, it's also just giving them the tooling and the insights that they know they have the confidence in the systems that are kind of handling this for them. I really don't think you're going to get far if you go to a developer and you're like, hey, you need to change your configuration settings. This is costing us a lot. They're almost never going to be incentivized to do anything about it because their goal is deploy new applications, move the business forward. And so I think I would say it's harder to incentivize them to do the work than it is to give them the tooling that allows the work to be done for them while they can get input into the tooling. So like if you say, hey, I'm going to do this for you, you have no insight, no ability to override anything, no ability to constrain it. They're going to be like, no, you can't do that. For example, you can take in their concerns and codify that into the system that's doing the fixes for them. Then they're a lot more incentivized to kind of move this forward because it's less work for them and they get the better outcome.
So I can see like one of the core problems here is that maybe the team that's fundamentally responsible for managing the application, like building it and running it, the development team, the DevOps team, how do they get the knowledge for what should be reasonable as far as spend goes? I do see this disconnect. Like, do you have any?
I mean, it definitely depends on the organization of like how much they're spending because scale's different, right? Like a very, very large bank is going to be spending a lot more than a 10-person startup. Not always, because sometimes, especially with AI tools, 10-person startups can be spending a lot of money. But the metric that we usually look at is waste percentage. So of everything that you're doing, how much of it are you actually using? And that's usually a better metric to go to folks and say, did you know you're like wasting 70% of the resources that you are paying for. So we don't go in and say like you should be spending less here and there, because sometimes you want to be spending more. It's just, are you efficiently using the dollars that you're spending?
Do you think that may optimize for the wrong thing though? That if you encourage teams to have high like capacity utilization for their pods nodes, or if they're using something else, let's say virtual machines, just like, oh, the CPU is only at 5%, we should use a much smaller machine to achieve the same thing. Optimizing at that level may be optimizing the wrong part of the application. Like maybe the issue isn't that the utilization is too high or too low, but the thing that they've built is just wrong altogether.
Yeah. Yeah. Oftentimes it can also be just the app itself, the way that it's architected. And even sometimes when you right size, then you end up with a smaller but higher number of pods. And all of those pods are going to be making network calls. So like it's a lot more complex than just looking at resources. You do have to look at the whole system. And so you have to look at the actual application itself, how it's consuming metrics. Maybe it needs some changes within the application. What can you tweak and tune there? There's no like one size fits all. Here's what's going to save all your problems, but it's what can you start with and what's the lowest hanging fruit. I mean, honestly, lowest hanging fruit for most people is just shut off systems you're not using. And it's surprising how often that is the majority of the waste in an organization.
That's actually surprising to hear, because I feel like Corey Quinn, if you're familiar with internet personality, often jokes that the highest cost per utilization is your backup cluster, or your database backup. You're never using that, and yet there's a huge cost associated with it. I mean, there is something to be said, like understanding your utilization patterns to be able to eliminate the waste in that way. Is that real? Like, are we talking about like 50% of the cost is just right sizing and then you're done?
Honestly, typically like 60-70% of the waste is just, it like sounds kind of a little embarrassing, because you're like, it's just set your CPU request, set your memory request. We're talking about two settings. And I feel like in the VM world, that was at least a little bit easier to say, go set it. But in the container world, you now have sometimes millions of containers, and each individual container has different resource needs. And so it becomes more of a scale and like toil problem than it's anything else. So I do think a lot of the waste, or at least what we see is a lot of the waste, is just in right sizing. But honestly, there's also, so we track, you mentioned storage. We track kind of unused storage and backups that you haven't touched in 90 days. And the amount of POCs that we come across, and we're like, just turn this on and see what happens. People are like, oh wow, I got a lot of waste there that is just easy. Go remove it, delete it, turn it off. It's surprisingly more often than I would have expected.
Oh no, I'll add to another problem I have seen. So it's also not just like a set it and forget it kind of thing. I have seen issues where you have like a portion of the app that is maybe not touched as often as the application grows. Like if they're only deploying it every 6 months, suddenly what you've requested, like if you do a redeployment, but if you don't kind of babysit that, you can run into problems too, because it changes.
Yeah, if you don't have policies in place that are continuously looking at this, like, okay, great, you were able to either right size or remove or downscale once, but then your application is going to change. And you mentioned like apps that change every 6 months. Some change daily. So how are you going to stay on top of that? And one of the other things you had mentioned earlier was just horizontal scaling of, you need more resources at 9 a.m. Tools like the HPA, like Kata, are great for that, because they see requests are increasing. Okay, I'm going to give you more replicas, allow you to scale horizontally. And that's awesome, because it'll always help you keep up with traffic demand. But if you're not scaled, if you're not set your configurations correctly, you're just duplicating waste across the board. And it's very good from a reliability standpoint, but not very good from a waste management standpoint. So you kind of have to take the vertical approach alongside the horizontal.
I had a train of thought, and I guess I got stuck on this a little bit. There is this aspect of, I know, especially engineers in this area tend to want to optimize everything. And part of that, there's a lot of products that come out. So I can imagine that someone wrote like some sort of AI-based product that like you deploy into your Kubernetes cluster and automatically tries to right size all of the CPU usage and pod sizing, whatever needs to be allocated. Like, this seems like a genius idea, right?
Are you describing Stormforge, or did you look us up ahead of time? So we don't use everyone's like, oh, I use AI. We use machine learning.
Thank you.
It's math. It's like something that I can't do. It's not some fancy AI. Like and we develop it in house. We have PhDs that work on this stuff. It's like patent pending. Depends on the audience. Sometimes you're like, yeah, okay, AI, machine learning, but like it's not the same. And I feel very passionate about just making that differentiation. Because I mentioned this is a scale problem. When you're looking at the different settings at this scale, then that just means it's a really complicated math problem. And so we use the math to help solve that problem. We do look at the trends in the data, like usage patterns, HPA scaling patterns, all of that. And then we pull the metrics straight from Kubernetes. It goes into a Prometheus database. And then our algorithms look at those scaling behaviors and come up with what those right configuration settings should be. You could say like, okay, cool, and anyone can do that and come up with the configuration settings. I think what makes us unique is two things. One, the horizontal scaling behavior we talked about before, where people usually use the HPA, Kata. Those are the most common tools when it comes to Kubernetes scaling. And so you have to work with those tools. You can't work against them, because if you're going to go in and vertically right size a container, for example, and it's horizontally scaling, then the HPA is going to be like, oh, well, you're using more of it. You've downsized, so using more of your resources. I need to go give you more replicas. And then the VPA or any other vertical right sizing solution would be like, well, okay, now you need more resources. So you get into that churn cycle. And one of the things we look at is your horizontal scaling behavior in addition to your vertical right sizing requests, and then set those together so that you can continue using the tools that you are using that are open source, that like I would never want to ask anyone to rip out, and then also kind of reap the benefits of vertical right sizing. And then the other piece is we've been talking about developers and how to incentivize them and input into it, is important for that confidence to be able to actually do this automatically.
You say that, and now I'm just wondering if this isn't a solved problem. Like, why is it that, say, the JVM or Kubernetes pods or even Docker containers, like, why am I, even serverless solutions, if I'm running on Vercel or AWS Lambda functions, why am I specifying like timeouts and CPU and memory usage? Like, why is it just not automatically determining based off of, I don't know, the last 10 years and daily load, but how it changes over week by week, month by month, where holidays are based off geographic regions? Like, why not just take all this stuff and just automatically figure out what the scaling capacity needs to be? Like, I guarantee you, when I was an engineer, I definitely could not have figured out like how many requests I was going to get a week from now, let alone a month from now, or how is that going to change based off of whatever marketing campaigns are being run, et cetera.
Yeah, so I mean, the VPA that is open source, comes with Kubernetes, allows you to do just basic, like, okay, look at my past, I think, week in usage, and come up using P95 with what my request should be. And for like basic deployments, that works, right? Look at what I did in the last week, and then use that and set my request for me. I think some of the challenges are the VPA, if it's scaling on CPU or memory, doesn't work well with the HPA, what I mentioned earlier. So you're like, if you're going to choose between something that's horizontally scaling you or vertically scaling you, you're going to go horizontal because it's more about reliability and how do you keep up with your traffic patterns, versus like VPA is more about how I reduce the waste. And then if you're an organization that maybe has more cyclical patterns, things change over time, you want to be looking at like a quarter's worth, a year's worth of data. Where are you going to store that data? How are you going to look into that data? It all costs money. So then that's where kind of vendors come into the mix. To be honest, if you wanted to build something yourself, you could, but do you want to be into the business of kind of building systems that manage your own systems, or do you want to be in the business of building applications that move your business forward? So that's kind of where we see it. And sometimes I talk to companies that have built something themselves and it works for them, and it's like, great, if it works for you, it works. Like,
I'm going to ask a really embarrassing question here because I am a self-proclaimed not Kubernetes expert. What is VPA and HPA?
HPA is horizontal pod autoscaler. So HPA looks at the target utilization. It looks at your CPU, and then you can set like a target utilization. Say, if I'm using more than 70% of CPU, I want more pods. So give me more replicas, copies of my my deployment. And it'll scale for you horizontally up as you need more, and it'll go back down as you need less. The VPA is a vertical pod autoscaler, and that looks at resources in a vertical manner of like, okay, you have X amount of CPU, so like you have maybe 100 millicore, you need 200 millicore, or you need 50 millicore. Does the same for memory, both of them, of course. but that is what allows you to scale vertically. These are both tools that are open source. So anyone using Kubernetes can be using them, should 100% be using the HPA. There's almost never use cases where you shouldn't be using the HPA, though there are some. But there are tools available for folks, and almost everyone. I think like Datadog did a survey now 3-4 years ago where over half of their customers or prospects, people that did the survey, were using the HPA, and like 1% were using the VPA. Since then, the number's grown, but it's still majority HPA because it's very easy to use. It makes sense to be able to scale horizontally. And
So one of the things that I think could be interesting here is you said basically the number one thing that should be done is maybe time-based load management. So reducing your capacity, scaling down when you don't actually need these resources. I think this resonates with a lot of cases, especially not that long ago. And I'm sure there are still some companies that are doing this. They have managed action runners for GitHub or workspace runners for GitLab or whatever they're using for CI/CD, and those aren't being used when no one is doing software development. And obviously, in this more remote world, that's harder to predict over time now, I think. But if that's number one, and I think that's sort of the obvious one, like what's number two and number three of what people could be doing or you frequently see as problematic or high cost and could easily be cut out, or maybe not so easily?
yeah, so we talked about AI earlier, and just like everyone's doing something AI. A lot of people have a bunch of data jobs, like they're using Spark. And so it's fairly easy to deploy jobs on Spark. And what I've seen is people will have a lot of waste in, kind of similar how GitHub Runner, like it'll go do a bunch of stuff. How long does it take to go run and go do that stuff? How many resources does it take? Typically not an area you're going to go optimize because you're like, okay, well, it lasts maybe a couple minutes, if even, maybe it's under 60 seconds. But when you start to do that at scale, very similar to Spark jobs, that becomes a challenge because now you're running tens of thousands of these data jobs that are very compute intensive when they're running, and then they go away. And how often are people pruning them, making sure these are jobs that are actually still relevant to the application? What I've found is when it comes to AI related things, people are less thinking about how am I going to optimize this, more just, okay, spend. I need to just run it. Like GPUs come up often too. And people will ask us like, oh, are you optimizing GPUs? And my next question will be, would you actually optimize your GPU? Like, do you have any initiatives? And they're like, no, I just know it'll be a problem in a few years. And I'm like, okay, yes. But right now, but when people get R&D budgets, there's just give me the fastest, most powerful system that I can put together. They're not really thinking about, okay, is this actually cost effective?
I think is a really interesting path to go down, because I know historically, at least in my career before I moved slightly outside of hands-on software engineering, the joke amongst a lot of my leadership was there's no reason to optimize costs in any way because the amount that we're spending in the cloud is just completely dwarfed by whatever else thing we're paying for. Usually it's engineering salaries by like factors of magnitude. But as we get closer to having companies with smaller size and more hardware requirements, especially given the hardware requirements for running ML workloads or data jobs, or specifically running models, open source or otherwise, there is a huge increase in cost there per engineer, right? And I don't think I think the mentality has actually gotten worse, right? Like it used to be much more conservative when like which tools will we use, which cloud providers will we use, what will we write? And I feel like now it's gotten way more liberal, like, no, go as fast as possible, pay as little attention to this. Are you still seeing companies be like, okay, no, we actually need to think about this methodically, like we know it's going to cost a lot to run our models, or is it really just a VC race?
It's definitely a race for sure. Like every time I open up LinkedIn, I get these posts about like these companies that had 2 employees or 10 employees and achieved this much. And I'm like, yeah, I wonder what they're spending on the public cloud providers. But we do get the question. So it's rarely are people like, I actually want to do something about it. But we talked, we kicked this off talking about FinOps and DevOps and bringing that together. The FinOps teams are the ones that are asking the question. When I was at FinOps X a month or 2 ago, I got the question about GPU optimization often of like, how do I manage the spend here? And the thing I didn't want to say is like, honestly, your AI ML team is just going to spend whatever they want, because is anyone giving them that guardrail of don't spend? But it is great that the FinOps team is thinking about it, because they know this is going to be a challenge. And it starts with visibility, because as they are building the case of, hey, we should maybe put some guardrails. I'm not saying go tell the team they can't spend any money, but like some guardrails is okay. Getting the visibility is the first step to that.
Is it just async background jobs run by quote unquote data teams that are, trying to make the business run, or?
I think it's definitely a mix. I'll even just like talk internally about CloudBolt. So we talked a lot before about the machine learning that we do, but we also do have, like, we're working on a chatbot where you can ask questions about your infrastructure. And I get this question often from FinOps people is like, I don't want to put them into the reports and have them figure it out. I just want them to ask. Now everyone has learned how to interact with a chatbot. That we get our main practitioner being like, I just want my end users to ask a question of what was the AWS bill for the last month, and how did that map to what we had put in our budget. And so we are actively kind of developing based on a lot of the libraries that are out there and exist today. And so it is a mix of, okay, I need the infrastructure to be able to deploy, and what I do my training on is different than what I do my inference on. So there is, like, I'd say because we have some history in building the tooling, we are a little bit more cost conscious than other organizations would be. But we use that to then say, okay, if I'm an end user, what is the information I would need to be able to look at?
It sounds like it's not necessarily FinOps which needs to happen now, it's FinMLOps. Is the primary focus of CloudBolt to be a much smarter version of the VPA and HPA? Is that the set, like, hyper focused in this area, or is there like extended integrations?
Yeah. So CloudBolt is a portfolio of products, and the Kubernetes focus comes from the Stormforge acquisition. That's like kind of my background. That's probably why I talked about it a little bit more. And that is Kubernetes right sizing. So the ability to actually look at your traffic patterns, use machine learning to come up with what your right configuration settings are. And we're currently building that into the CloudBolt platform, which is a whole slew of things. And the CloudBolt platform pulls in billing data from AWS, Azure, GCP, and it does all that with the focus spec. So the FinOps Foundation came out with the focus spec to basically be like, hey, everyone needs to talk the same language. Like, it is, it's hard enough to give people the right insights. Now they have to know, what is storage in AWS compared to Azure? And when you're talking to FinOps folks, not all of them know all the technical terms. So how can we abstract that? We rebuilt our data platform to be focus native, so we can automatically pull that information and give you reporting and visibility across all your public clouds or anything private like VMware, OpenStack, Nutanix, all of that, with that one language, one abstraction layer. And then you can interact with a chatbot that we're still working on. So I'd say it's in beta. It's not like publicly available yet, but we are using it internally. It's pretty cool. And interact with your data there. You can do your cost allocation to say, okay, these different departments are often, like, we have a lot of MSP customers. And so it's like the cloud Ponzi scheme. Someone's buying cloud from someone, then selling it to someone else, and they're selling it. And every layer you need to understand, what are the discounts that get applied? What are the margins I want to add to this? How do I make sure that third tier customer is only seeing what they should be paying for, not what I'm actually paying for? Because that could get a little hairy.
Let me ask a question. Like, technically, how does this actually work? Like you said, we're looking at like traffic patterns. Like, how is it actually intercepting and reading those traffic patterns?
Yeah, there's an agent that sits in the cluster. It pulls the metrics from like CAdvisor, pull like cube state metric type metrics. It's a couple pods that sits in the cluster. It's not a daemon set or anything. And then pulls that information out and then reports it into our database. And that's one source. So we also have an agent that pulls metrics from like VMware, for example, looks at that utilization data. And then with the focus spec, we can overlay information from like your billing reports, and then put that on top of like all the utilization metrics.
Okay, I always get nervous when you talk about like adding agents. So the agents are not sitting like within like a current deployment or something like that, because then it's like, okay, now I have like more research and requests that I need to account for on top of to solve this problem.
Yeah, totally. That's people are very sensitive to agents. The word, I mean, So we talked about it
But
before.
not agentic agents, but
Yes.
agents living inside your cluster. Yeah.
And what the Stormforce software actually does is we use our own software to right size the agent so that we can make sure that the agent is just using the resources required for that cluster. And they're two lightweight pods, at least in the Kubernetes space. When people have agent based tools, a lot of times they're daemon sets. And so they take up a lot of space on every node. And we've taken a deliberate approach to have a very lightweight agent that is just two pods that script the metrics and send them out.
Is it a security concern or like a capacity utilization issue of our resources in the cluster?
I've actually seen it as a capacity issue. So I've seen people like deploy agents for various things and suddenly have capacity issues with because everybody's fighting for the same resources. But if these are like you're saying cyclic deployments, I feel like that's less of an issue at least.
You have some like previous trauma there.
Previous trauma, it seems like.
Is there something that we can shame specifically?
I actually can't recall the exact product.
Well, let's just start like this. Is there a frequent concern with pulling in open source, definitions into your cluster without really evaluating how resources they're going to consume compared to something
Most definitely.
Building yourself?
Yes.
And is that the source of most of the problems, or because these things aren't necessarily built for like I always complain about the security of open source, not libraries, but full services that you deploy within your cloud environment or a cluster, because they're not designed for scale and reliability. They're designed to usually funnel you into their paid product or licensing. So, it's like always a concern from that standpoint. So I can imagine an equivalent issue where they're not really designed to have low impact from a cost standpoint either.
Yeah, I mean, I'll chime in, I guess, a little bit, but I'm also curious, like Yasmin's thoughts. But at least just what I've seen it's less of a security issue, but more of a resource issue.
I mean, on our end, because a previous version of our same product did actually use a lot of resources inside the cluster, and customers would be like, I'm using your tool to reduce my waste, but I also am wasting resources to use your tool. And so when we kind of went through a re-architecture, that was a very important piece for us. Also because, I mean, it speaks to our credibility. We're supposed to be reducing resources, then our own bits should also be using limited resources. So that is why we take a very lightweight agent approach. And it's actually not an open source agent. We've gone back and forth of like, should we release the code? It's not like it's anything secret. It's always been a private agent. But people can see the Helm chart. They can see what resources we'll deploy with like default requests so that obviously everything's capped. But then people will use the software to then right size it to make sure it is literally just using the minimal required resources. And it's sized to the cluster too. So if you have a small cluster, you're not spending the same amount of resources than if you had really like a large cluster.
Smart.
I have some PTSD from agents because I spent a lot of time at Puppet, and there was a lot of agent wars at the time, to the point where I like hated the word. But I've
Well, I guess I could say maybe I'm glad that you have some PTSD from working at Puppet, because I definitely have some from using Puppet. But that was a long time ago, and it's been quite some time since I've had virtual machines even to run stuff on. Now I feel like I read some statistic like still 50% of the world uses some PHP backed builders for websites. So I mean, there's still a huge amount of people that aren't even using any sort of infrastructure as code solutions. And I'm over here saying, isn't everyone pretty much using some IAC and deploying their stuff directly and spinning up containers? Amy's already shaking her head to either mean she has a really great story to share or a really great story she doesn't want to share.
I don't know. It's a lot of people will try to do the right thing, and then other people are just gonna try to do the quickest, what seemingly works solution, which is just click it and go. But I see it. I see it so often, and it irks me.
I mean, there is a huge aspect here where it's about aligning incentives. So I think most people in general have a logical desire to do something. They see some initial conditions, and then they follow their path as best as they can to come up with the action they want to take. And part of that input is whatever incentives they have to go forward. And sometimes those incentives, aren't aligned from one team member to another one, or from one team to another one. Like you give certain incentives to your engineers, and then you give different incentives to non-engineers or release folks or engineering folks, product management, or we talked about having financial operations folks, have responsibility of actually reducing the costs, but separate from not actually making sure that the products that you're building have low footprint, right? And so you immediately have a difference of incentive there. So, I think there is a lot that goes into that sort of poor decision-making process where you get suboptimal outcomes when your organization as a whole doesn't have this included. And I don't remember the last organization I was in or the last company I was talking to that was like, yeah, in our objectives and key results, our OKRs, we actually have like reduced the total cost associated with our infrastructure. Although I feel like, everyone's gonna be like, yeah, of course you need that. Of course you have to counter your new development. But I don't think a lot of companies are doing that, are they?
No, it's funny. When I ask people, I'm like, oh, like how important is like reducing costs? They're like, it's a top priority. I'm like, oh, okay, can you rank like your top priorities? And it doesn't even make the top 5. And I'm like, well, you just said reducing costs is important. They're like, well, yes, we have the security thing we need to do with this new application we're trying to get out, and it's always competing. That's why I think like any solution is going to need to take minimal time and just work inside a system. So you can be like, okay, this is low hanging fruit. I can go tackle it. Even if it's 6th on my list, it's still in the top 10. But it's like, it is really interesting every time I talk to an IT leader and they're like, yeah, it's so important for us to cut costs. And then I'm like, okay, rank your priorities. Where does it actually sit?
If you are mature enough engineer, you kind of treat this as like just your bread and butter, as like part of your job. So like, yes, it helps to have the incentives there. In my opinion, I feel like if you're going into that role, like this is not something like management should tell you like, oh, we need to reduce costs. Like this is just like a given of like, as part of the reliability metric that people measure, like the cost metric should be something that you just go to your management team on a quarterly basis and be like, here's the cost we reduced, or here's what we did.
I like that perspective.
Like you shouldn't have to be told to do it.
If you're an inexperienced engineer, or even a senior engineer, you may have your own internal metrics for, say, when to pull out a public package or open source solution. Like, oh yeah, I go to GitHub and I look and I see there's 15,000 stars. That means, yeah, sure, I'll use it, no problem. There are ratings there that are, and I feel like as you ascend the sort of competency ladder and you get to staff plus principal engineer, you're not like, you need your own sort of internal metrics, and I feel like you're increasing the scope of your delivery at those higher levels, and there has to be a trade-off. Like, how do you make sure you're doing the right thing? And I totally agree with you, Amy, that part of it is like, well, how much am I spending to make sure that this technology that we release to have a business impact is costing us the right amount to actually have a positive ROI for us and not be negative?
See, I would say like, just like if you enjoy your job and you're looking at your runway, like this should be something that is consistently top of mind. And I mean, through no fault of like more, newer engineers, this is just not something they think about. It's not something I definitely didn't think about my first 2 years. I was just like, oh my gosh, I need to get this feature out.
I think there is definitely a cliff function here, and maybe either of you can correct me, but I feel like there's a switch where early on in people's careers, they assume that the money that a company is spending is their own money. Like, oh, this price tag is like, we get customers all the time. Like, oh, this is like going to be 10,000 a month. That's too expensive. I'm like, how much are you paying your engineering team to maintain that solution that's not even working? And how much are you paying your cloud provider to run that solution for you? I assure you, it's like at least 10 times how much you'd be paying us. And then there's a switch later, I feel like, where they're on one of these two sides of extremes, right? Like the money doesn't matter or the money matters too much. And I think just like everything, I think the number one answer staff plus engineers love to give is, it depends, right? How much should we spend on our stack? Well, what are we running? How important is it? What's the reliability necessary? I do want to ask you a question, Yasmin, though, is that let's say I am in one of these roles, and while we all collectively agree that you should have the responsibility and accountability for either running some sort of solution that handles auto scaling, pulling in the appropriate SaaS or open source solutions to help you. What if I'm not given that flexibility? Like what can on the ground engineers do to help make a case to say their leadership or their teams to have a more, I'll say, mature perspective on how to approach the problem?
The first question I usually ask people is like, what do you think your cluster utilization is? And they'll guess. And usually they always guess higher than it actually is. Then they'll go look into whatever monitoring system they have and they're like, oh, wow, it's like 20%. And I'm like, okay, what if you just doubled that, right? Like, I'm not saying go to 80%. I'm just going go from 20 to 40% and setting that goal to be something that's achievable. Typically, I found that is something people can do on their own without tools and just get an understanding of how bad of a problem do I have and how much waste is there. Because when you go to people and you're like, hey, we could remove waste, then it's like the language, you're removing something. There's a risk in that. But when you say, what if you could improve your cluster utilization from just double it from 20 to 40%, you still have 60% headroom. Like there's still a lot of waste there. But you've doubled your impact, right? That's a pretty good metric that you can feel good about.
I do see this fear of like, I don't want to touch something I don't understand because I don't want to break it. Like maybe it's 20% right now. But I think the other thing that we hear frequently on the show is like, how as an inexperienced engineer do you get to some sort of depth? I get asked a lot when I'm giving talks at conferences, like, how did I become a security expert? I'm like, I have no idea. I guess I just spent a lot of time doing things. And I think this is one of those areas, like if you see the capacity is really like utilization is really low, like maybe ask the question like, well, why is it so low? Like, what should it be? Like, you don't have to change anything, but maybe you should be able to answer like, well, if I wanted to change it, what steps should I take? How should I know what it should be? Like, what information should I pull out? I think that's really good advice.
I went back when I was an engineer, I learned everything by breaking things. Made sure I broke them in dev, but like you don't learn until you try. And so as long as you have a safe space to try and you have a cluster in dev that doesn't matter and it has really low utilization, you can practice different ways to improve that on a cluster that doesn't matter until you kind of hone your skills and go deploy it to other environments.
You can definitely say no comment here if you're not comfortable answering this question. But like, surely people were concerned about the cost of the cloud before moving there, or the cost of their, container management solution, or fleet of virtual machines if they were using vSphere on VMware. Like, weren't there like solutions? Like, weren't people already talking about and doing this before?
Yes, but there was an expectation that moving to cloud would be cheaper. And then there was a reality that like you have to put in work to actually make sure the cloud is cheaper. And most people didn't put in that work. So now they're paying for it.
Do you think that that's like a huge driver for the let's move off of cloud because it's too expensive? And you're like the voice of reason here. It's like, well, it doesn't have to be too expensive. It can be the right amount of expensive or even cheaper if you just think about what workloads you're running and what their capacity utilization and how to scale effectively.
Yeah, I think like everyone wants this ideal world where they don't think about day two problems, but it doesn't matter where you're deployed, you have to think about day two problems. And the reality is for some people, probably moving back to the data center is the right thing. And that's okay. Like there is this, oh, you have to be on the cloud to be cool, which like I think people are starting to get that you should be on the cloud for the right reasons. And if you are there, you need to be thinking about your day two challenges, like making sure your configurations are set correctly, like you're reducing waste, you're doing the right sizing, you have policies to go clean up unused backups, just, basic things.
I just want to totally disagree with you. I mean, I think it's a very mature approach to say, there are reasons that you may want to go to an on-prem data center, but like my justifications for doing that are just drying up one after another one. Like I think about just the depreciating assets for on-prem. Like it used to be the case for sure that you could buy a data center or even rent a data center and throw your own server blades in, and those would be usable for a decade or even 20 years. And now I feel like, especially if you're doing something cutting edge technology and you want to do some data evaluation or build some models or run the models and do inference, the technology to maintain a competitive advantage actually requires frequent hardware upgrades. I don't know. I actually would love to someone to tell me like, no, actually, here's this area where it makes sense to actually be on-prem. But the more simple, the more straightforward, the more common what you're doing is like everyone else, the less of a reason there is. Like it really should be cheaper being in the cloud for me.
I think for most startups that are also like deploying to cloud native applications, makes sense. You still got to think about day two. Otherwise, you're just going to spend like crazy. But like you still have retail companies that have been around for a while and have like OMS systems that are not built to run on a public cloud. So it's you're shoehorning something that's just going to cost you in the long run. And because I mentioned our our history of like being a infrastructure automation platform for the last 15 years, we see a flavor of every type of infrastructure you can imagine, like things that are still running in a data center somewhere on tapes. Like it still exists, and not everything makes sense to move, because if you're just going to lift and shift it, then you will be paying more.
It's interesting because it was never for me that moving to the cloud was actually a cost reduction. I mean, I believe it's a reduced cost if you build the right thing directly, but like my like personal motivations were always like higher reliability, getting cutting edge features and support, the infrastructure platform, whatever you're utilizing, and being able to have quick development cycles, be more agile. And I feel like in the agile world with just-in-time technology, there is a cost associated with that. So like I do see it as paying for the advantage. I also like the mentality of like, well, it actually doesn't have to be more expensive if you utilize what the cloud provider is offering. It's interesting to see that you still engage with companies that are running off-prem, and it just will like forever always be cheaper.
That 50% metric honestly doesn't surprise me. It probably did before we got acquired, because I've been living in the Kubernetes world for so long. But the more and more I talk to different customers and prospects, that there's still there's a healthy mix of on-prem, and even honestly within Kubernetes, people running Kubernetes on-prem.
I used to trust them. I mean, so I'll say where this is from. Like, I think it was like every year WordPress would come out with a number of like the percent of the internet that was running on WordPress, and like I never liked PHP, so I wasn't particularly inclined to trust the numbers coming out. But after every local recent scandal, I even trust those numbers less. But whatever that number is, it's still higher than I would be comfortable with, as a human society, that we're overutilizing this. So there are tons of non-tech 0, 1, or 2 person companies that, before the Webflows and Lovables of the world, Bubble IOs, there was like, you needed to get your website up and running, and GeoCities and whatever Yahoo had, just Google Sites, was not cutting it. So you did do this, and with a number of themes and plugins, like I do get it. But that means like they can't utilize any of this, and the cost for those is of course really high, but they have no value in transitioning to whatever. Think of like your local hairdresser, like they're not going online. I mean, at this point though, I'm sure they're using some SaaS product to manage all their scheduling, and LLMs to actually do the hairdressing itself.
That'd be great. Ask a chatbot like, how should I cut my hair? I guess you could. Never thought of it.
Well, I just assume you're not too far out from asking the chatbot, like handing it the scissors and telling it to do what it thinks is best.
I actually saw a video the other day of one of Musk's robots doing haircuts.
Oh, God.
Yeah. We're not going to go into that topic. Otherwise, I think I'm going to actually have to cut it out of the podcast episode. So
I'm just stating the fact. There's no opinion there whatsoever.
Well, I think for some people the facts are even up for debate. So
I mean, yes, it was a video. I'm like, did an AI just make this video, or is this like a realistic video? I don't even.
I can never tell. Honestly, every video I watch, I'm like, is it real? I don't know.
There was something I'll say that was really interesting, totally unrelated. There's a British comedy show called QI, quite interesting. And every season they would say facts. And they, by like the 13th season, what they had done is they actually calculated the lifetime of the facts. So what they said earlier on became less correct the later the season would go. So like, it was like, the previous season, like N-1, 86% of the facts were still correct. But like the first season, by the 13th one, there was like something like 60% of the facts were like just no longer accurate. Like science, like whatever we had decided, different now. And I think the canonical one is like the food pyramid. Like what is the food pyramid supposed to be? Every year there's a different change to it, and it's never accurate. I think before we go too much down another tangent, maybe it's a good time to switch over to picks. Mostly nods here. So Amy, what did you bring for us today?
I debated on this because I don't want a lot of people to go out and buy it, and then they have like they're no longer able to fulfill the orders, but it's really good, so I feel like I should share. I'm a big health person, hence why I'm walking on this treadmill. And my pick is going to be like a specific protein powder. So when I was like new on my protein powder journey, I didn't quite care. I was like, what does it taste like, and what's the price? So this stuff is a little pricey, but it's like super clean ingredients, and it's the brand's called Equip. The other good thing, they have a protein. I feel really embarrassed, like maybe other people are not into this, but in case someone is, they also have a protein bar now, which like if you travel for work frequently, I'm always like, if I have to go to a conference or something, like I need something that is going to not like make me feel like trash when I'm there, because sometimes the food doesn't always, I don't know, it's not always the best. So anyways, they have a protein bar that just came out. I had to order it like a month in advance. That's how special this protein bar is to me. And I just got it and it's delicious and that's it.
You did Peloton last episode, so we clearly on a health kick here, I guess.
I'll try to think of something else next week.
You don't have to. You can definitely bring how to live a healthy lifestyle picks every single week. I think especially for those of us who sit at our computer, like literally sit at our computers all day long. I think there's something good to be said for that.
Actually, here's something practical about it. It's not just healthy, but a lot of people who are like trying to transition, I hear like a lot of my coworkers are like, I want to get healthier, and they switch to a protein powder. A lot of protein powder is whey based, and that can upset people's stomach. So this one is actually made from beef protein, which you might think like initially I was like, this sounds disgusting, but it actually tastes really good.
That's a pretty good sell there. Okay, Yasmin, what did you bring for us?
So initially, I think I had more of a fun fact that I learned this week than a pick. But since we're on a health pick topic, I've been having bone broth recently. A friend got me into it, and I've been drinking like beef bone broth, chicken bone broth. There's one on Amazon that I buy like 1990 snacks. It's like an orange container. I'm sure they're all good, but it's like actually really good. Instead of a tea or just a lunch snack, if I'm like, oh, I don't have time, I'll just heat it up. And I think maybe it was a thing that everybody else knew about that I didn't know about. But yeah, I've been really getting into that lately.
They're also good for travel.
I've never heard of it, and I don't think I'll ever have it. So
you should try it. You should just try it.
You
once.
really okay? Here's an idea to use it too. Like if you don't just want to drink it, like if you ever have some sort of like pasta, you can cook your pasta in it.
So I absolutely go to the store, or actually a lot of butchers will throw away bones. You can go and just ask them for the bones, and you don't need to buy beef bouillon or chicken bouillon at the store or vegetable stock. Honestly, just boil the bones and some vegetables. I usually use carrot or celery and a bay leaf in a pot for like an hour or two, and then use the liquid for whatever else you're making. And it's just so much better.
I like your idea better.
Just try drinking it. Just try it. Even if it's just a sip. It's good.
I don't know. Like I find for me that the best broths are like usually when the meat is a little bit fatty. So if you use like chicken thighs instead or wings, like instead of breasts and pork or beef bones, like I don't have that much meat, but like there's a lot of flavor here. I still think it's like too fatty for me. Like I don't like the sensation of having like a fatty drink like that. That's the idea is warming up to me, but it's a lot of extra effort to go out and do this. But I suppose if you live close, or you buy whole animals to cut up and consume, then you have probably a lot of extra bones. And if you're not utilizing them to also make drinks, I guess here's your opportunity. Okay, so I actually wasn't sure what I wanted my pick today to be, so I went and I grabbed this article called "Lions and Dolphins Cannot Make Babies," and it sounds pretty obvious on the surface. I mean, obviously they're in different families in the taxonomy for animals, but the article is about basically how we got to this point in technology required a synonymous relationship, symbiotic between whatever the hardware we're utilizing and the software that we're building. And I think this is true in a lot of things. It's known as in evolution as the Red Queen's race. So you think of like bacteria and viruses competing for resources, or even any sort of parasitic organism and the host evolving. And it goes into a little bit about how we probably will not have any more innovation in AI unless we really take a huge giant leap in some of the hardware technology available to us. We can't just build better software and fix some of the problems. I mean, right now, I think one of the limitations we have is everything that's built in the last 6 years was based off of the paper written by Google on transformer architecture. And like, sure, there are some shortcomings, like it can't figure out patterns or do math, but we'll extract some characters from, you can ask it like, where is the math? And then like regex that and then pass it to any sort of solver engine and get that. So, you start to solve some of those problems, but fundamentally to get to the next level, we'll need something different. And it's not just writing new software. I think the idea here is fundamentally that we're stuck until we actually understand that we may need a different kind of hardware to power this. I don't know if quantum computing is sufficient to running this, but really just something that's slightly different from our current computational engines.
Love to read that.
It's not very long, so I think I may be overselling this, but it'll be in the link to the in the podcast episode in the show notes. Thank you so much for our kind guest to show up today and tell us all about FinOps. So thank you for coming. It's been fantastic. And thank you to all of our listeners for another great episode of Adventures in DevOps. And I hope you're all back for the next one.